This is chapter Arithmetic Progressions. If we consider the following sequences, first case we have 5, 8, 11, 14, 17. As you can see, the terms are increasing by 3. So here we are adding 3. Again, each time we are adding the same constant. So the next two terms will become 20 and 23. So here each time we are adding 3. In the next sequence we have 5, 10, 15, 20. So it's quite easy. We can see that the terms again are increasing by the constant number 5. So here we have plus 5, plus 5, plus 5. This will become 25 and then 30. Part C, we have 100, 90, 80, 70. This time we can see that the terms in the sequence are decreasing. So here it is, we are adding minus 10. Here also we add minus 10. Here we add minus 10. Here we add minus 10, it becomes 60. We add minus 10, it becomes 50. For arithmetic progression, we talk in terms of adding. So we don't say we are subtracting minus 10. We say we are adding minus 10. We are adding a negative term. So in other words, it will become 100 minus 10. But we have to say we are adding minus 10. We are adding a constant term. For part D, we have half, 1, 3 over 2, and 2. So here we are adding half each time. So 2 plus half, this becomes 20 half, or 5 over 2. We add half again, we obtain 3. And then the last part, we have minus 2, minus 4, minus 6, minus 8. Then we will have minus 10 and then minus 12. Here again we are adding minus 2. So we are adding minus 2. So in all these cases we can say that each term differs from the term before by a constant, and this constant is common in each case, and we say that this constant is called the common difference. And these sequences, we call them arithmetic progressions. So now we have the notation that are used for arithmetic progression. We have A, which denotes the first term, D, which denotes the common difference, and the letter L, which denotes the last term of the sequence. So in part A, we can say that A, that is the first term, is 5, and the common difference D is 3. Here in the second part, we can say that A is equal to 5 and D is equal to 5. Here, third part, A is equal to 100 and D is equal to minus 10. Here, part D, A is equal to half and the common difference is half. And the last one, a, that is the first term, is minus 2, and the common difference d is minus 2. We can also see that the common difference can be positive or negative. It can also be 0. For instance, if we have 5, 5, 5, 5, so this also is an arithmetic progression. We have a is equal to 5 and the common difference is 0. We are adding 0 each time, so the common difference can be 0, positive or negative. Let's now consider the terms of an arithmetic progression whose first term is a and whose common difference is d. So we have the first term, which is a. We can write the first term. We use u subscript 1 to denote the first term. So u1 is a. The second term, so this is the first term. The second term, we can write it as u2. So if the common difference is d, so the first term is a, the second term we have to take the first term, we add the common difference. So the second term u2 is a plus d. Third term u3. Now to obtain the third term, we have to take the second term and we add the common difference, which is d. So we have a plus d plus d. So it will become a plus 2d. So this is the third term. For the fourth term, again, we proceed in a similar way. We have to take the third term, which is a plus d, and then we add d again. It will become a plus 3d. Fifth term, u5 is equal to a plus 3d. We plus d again. It becomes a plus 4d. So as you can see, for the second term, we have a plus 1d. So we have 1d here. For the third term, when we have u3, it is a plus 2d. So when we have 2, here we have 1d. When we have the third term u3, we have a plus 2d. That is, we take the first term and we add twice the common difference. For the fourth term, that is when we have 4 here it will become 1 less. It is a plus 3d. For the fifth term, you will see that here we have a plus 4d. So if we continue this pattern, so if we have the sixth term, it will become u6. So when we have 6 here, it must be 1 less. It becomes a plus 5d. If we go on like this, 10th term, that is u10, this will become a plus 9d. 10 minus 1 is 9. So for the 20th term, we will obtain a plus 19d. And then in general, if we have the nth term, will be denoted by un. So here it will become a plus. So here we have n. So we have to take n minus 1 times d. So we have obtained the general formula for the nth term of an arithmetic progression. Therefore, we can write it as the nth term of an arithmetic progression is given by un is equal to a plus n minus 1 d. So if you want to know any term of an arithmetic progression, we just have to know the first term and the common difference. These are the only information that we require. We can find the 100th term, the 50th term, any term of the sequence. So again, I repeat, we need only the first term and the common difference of the arithmetic progression. And also, to obtain the value of the common difference d easier, we just have to take suppose we have 8 and 11, we take the third term and then we minus the previous term, which is the second term, we obtain 3. Here also we take 20 and we minus the previous term, which is 15, we obtain 5. Here we take minus 4 and then we minus 2. It will become minus 2. So the common difference is minus 2. So to obtain the common difference d, we can take un minus the previous term. So the previous term will be denoted by un minus 1. So this might be useful for you. Example. So d can be obtained by taking u3 minus u2, that is the third term minus the second term, or we can take u6 minus u5. Let's now tackle some examples. For each of the following arithmetic progressions, state the first term and the common difference, and part B, calculate the 12th term and write an expression for the nth term. So first one, we have 2, 4, 6, 8. In first part, we are asked to state the first term and the common difference. So for part A, the first term is 2 and the common difference is 2. We take 4 minus 2, we obtain 2. And for part B, we have to calculate the 12th term, and also we have to find an expression for the nth term. So the 12th term, we can write it as u12. And using the formula for the nth term, so we have to take a, and when we have n, we take n minus 1 times d. So when we have 12, it will become 12 minus 1, which is 11, times the common difference. So here it will be a plus 11 times the common difference. So it will be 2 plus 11 times 2, which is 24. 4. So we know that the 12th term will be 24. Instead of adding 2 each time until we reach the 12th term, we can get it directly by using the formula. Second one, we have minus 25, minus 20, minus 15, minus 10. So again, for part A, we have to write the first term, which is minus 25, and the common difference is, so if you are getting difficulty, you just take the second term and minus the first term. You will obtain minus 20 minus 25. So the common difference is 5. Next, we forgot to give an expression for the nth term. So the nth term un is a plus n minus 1 times d. So here it is 2 plus n minus 1 times 2. So we obtain 2n minus 2. It becomes 2n. So we obtain an expression for un, which is 2n. We come back to the second example. So we know that a is equal to minus 25, and we calculated d and obtained it as 5. So the 12th term, u12, it will become minus 25 plus 11 times 5, 55 minus 25, which is 30. And for the nth term, un, we obtain minus 25 plus n minus 1 times 5, plus 5n minus 5, minus 25 minus 5 is minus 30 plus 5n. Next we have x plus 1, x plus 2. The third one is x plus 1, x plus 2. So here a is x. We can see that it is an arithmetic progression because each time we are adding 1. So x to become x plus 1, we just have to add 1. Again, from x plus 1 to x plus 2, we add 1. So d, or we can take x plus 1 minus the first term, we obtain x minus x cancel, we obtain 1. For part B, 12th term u12, it is a plus 11 times d, which is 1 in this case, so we obtain x plus 11. For the nth term un, it is a plus n minus 1 times d, so we obtain x plus n minus 1. We leave it as such. And then fourth one, we have 1, 3 over 2, 2, 5 over 2. So the first term is 1. The common difference is 3 over 2 minus 1, which is half. Part B, u12, it is a, that is 1, plus 11 times the common difference. So this will give us 13 over 2. And the nth term, it is 1 plus n minus 1 times half. 1 plus half n minus half. 1 minus half is half plus half n. So this is the expression for the nth term. So we stop here for this lesson, but before we are going to do a quick recap. So as you saw, for an arithmetic progression, each term in the sequence differs by its preceding term by a constant, and you can see that the constant is the same in each case. That is why we call it the common difference. It is common everywhere. And then for the notation, we use A to denote the first term and D to denote the common difference. And the common difference can be 0, negative, or positive. And for the last term, we use L. So here we derive as a general formula for the nth term of an arithmetic progression. So the nth term, as we saw, it is denoted by un, and it is given as a plus n minus 1 times d. So to know any term of an arithmetic progression, we just have to know the first term and the common difference. So an easy way to obtain the common difference, we just take a term and we minus its preceding term. For example, we can take the third term and we minus the second term. We can take the sixth term and we minus the fifth term. And then we saw an example whereby we had to calculate the 12th term and also write an expression for the nth term. So that's all. Thank you.